Hello everyone, I welcome you to this video in which I will explain the core approaches in machine learning. So the first question is, what is machine learning? It is a subset of artificial intelligence, and the central idea is to allow computers to learn from data patterns and make predictions or decisions based on that. So machine learning approaches are commonly grouped into 4 categories. So the first one is unsupervised learning, which is mainly about clustering data points. Then in supervised learning, we talk about regression analysis and classification problems. In reinforcement learning, an agent learns by interacting with the environment and getting a reward. And in self-supervised learning, the machine learning models generate their own labels by using raw data. In this video, I'm going to talk about each of those 4 main types, and I'm going to explain the core approaches for them. Let's start with unsupervised learning. Here the goal is to find new patterns in existing data without using predefined labels. The main application is clustering, where we want to group similar data together. But there's also dimensionality reduction, where we want to identify the most important features in the data. So let's have a look at clustering. So as input, we have unlabeled data. Unlabeled means that we don't know that this object is an apple, the other is a pineapple. We just take the data as it is and give it to the machine learning algorithm, and it should group as an output similar objects together. So how is this actually done? One of the core approaches for clustering is the k-means clustering algorithm. And in this simplified example, we want to cluster the different fruits. And in the data space, you can see that we have 2 features, the color and the size. And at the beginning, we randomly initialize the cluster boundaries. And now we want to shift the cluster boundaries with the goal to minimize the difference within each cluster and to maximize the difference between the clusters. And the algorithm iteratively shifts cluster boundaries by reassigning data points to the nearest centers and recalculating those centers. So here in this example, we start with these cluster centers, and then we shift the boundaries with the goal to make the objects in one cluster similar to each other and to maximize the difference between the different clusters. And we do that until the final iteration, and this is the final outcome. We have clustered similar objects together. Let's have a look at some applications for unsupervised learning. We can cluster different customers based on their interest and purchasing behavior and offer specific products to the specific groups. In biology, we can use clustering to classify genes with similar expression patterns, which is important for discovering gene functions and understanding disease mechanisms. And in the energy consumption analysis, we can cluster different customers based on their electricity consumption and offer tailored energy compensation programs or tariffs to them. Now we're going to talk about supervised learning. Supervised learning uses labeled data to train models to automatically predict outcomes based on input features. So we have classification problems, which is actually predicting a category for giving input data based on learned patterns. So in this example, we have this picture and we want to classify the object as a dog. Furthermore, we have regression analysis, which is predicting a numerical value for giving input data based on learned patterns. So here, for example, we have recorded data about the salary and the experience of an employee, and a trained regression model should infer a function that maps the experience level to a specific salary. The most widely used methodology for this are artificial neural networks. They are computer models that learn and make decisions using algorithms by processing information like the human brain. And they consist of different neurons that are organized in layers and that are connected to each other, and these connections have some weights. And now we're going to go through a classification problem. So in the first step, we have the training phase. We use labeled training data, and labeled means that we know the desired output of the classification. So we start with the first figure, we propagate it through the network, and we know that the outcome should be a cat of the classification. Now the important part is that we adjust the weights of the connections such that the next time we're going to have the very same input, it will increase the likelihood to classify it as a cat. And we do the same with the next figure. We propagate it through the network, and we know that this should be a dog, and we adjust the weights such that the next time we're going to have the very same input, it will increase the likelihood to classify it as a dog. And we do this with all the data, and at the end we have a trained model that can now be used to classify new unseen data that the network hasn't seen before. So in this example, we just give this figure as an input, and it should output a cat, or in this case, it should just output dog as a classification result. So let's have a look at some applications for supervised learning. So one application is object recognition. In this case, we classify the different objects in a figure correctly. Then there's spam detection, so where the text of an email is analyzed and then it is classified as no spam or spam. Furthermore, predictive maintenance is an important part, where we analyze sensor data, for example, from wind turbines, and identify those ones that are likely going out of service pretty soon, and we schedule some maintenance tasks according to that. And one very important application is time series forecasting as a regression problem. For example, in this case with electricity demand data. So we use historic data and weather information to predict the future electricity demand. The third main type of machine learning approaches is reinforcement learning. Here an agent learns a policy by interacting with an environment and receiving feedback. So we have an environment and we have an agent, and the agent takes an action A. This changes the state of the environment, and this state is reported back, and the agent gets a reward R. And in the next iteration, the agent takes again an action A. This changes the state of the environment, and we get a state and a reward back. And then again we take an action, and this changes the state, and we get a reward. And so on and so forth, until we have learned how to behave in this environment based on the reward we have received. So another example here, so we have an agent that takes an action to go right here, and this changes the state of the environment, which is reported back, and we get a reward. And in the next iteration, we take the action to go up. This changes the state of the environment because obviously we died, and this state is reported back, and in this case we get a negative reward because it was a bad action. One fundamental algorithm in reinforcement learning is Q-learning. It makes use of a Q table, which stores every state and every action, and the Q values in the Q table quantify the expected future reward of taking a specific action A in a given state S. And the goal of Q-learning is to fill in this table with accurate values by interacting with the environment. So here we have an example. We have an environment with 9 states, and we have a cyclist as an agent that wants to go to his house. And here you see the Q table at the very beginning of the training. So we initialize it with 0 values. And now we start to update the Q table by interacting with the environment. So we start in state 1 and we take a random action of going right. And we get a reward because this action was a good one. And based on that, we update the action to go right in state 1. But we have a discount factor. This is why we don't use the full reward to update it. And now we're in state 2. So now in S2, we have the next iteration. We randomly choose the action to go down. And this gives us little reward. And based on that, we slightly update the action to go down in state 2. And we're still in state 2. And in the next iteration, we randomly take the action to go up. This was obviously a bad action, and thus we get negative reward. And based on that, we update the action to go up in state 2 negatively. And now we start with a new episode because we crashed. Now in the next iteration, we take the action to go right in state 1 because this has the highest Q value. We get a reward, and based on that we update the action to go right in state 1. Now we're again in state 2. Here we take now the action to go right, and this is a good one, and we get a high reward, and based on that we strongly update the action to go right in state 2. Now we're in state 3, and actually we're continuing to do that for many iterations and episodes until we have reached the final Q table. And now this final Q table is used by the train agent to interact with the environment. Let's have a look at some applications for reinforcement learning. It is strongly used in robotics. For example, to navigate in an environment with obstacles. It is also used in algorithmic trading and finance. An agent can learn to buy stocks whenever the prices are low and to sell them when the prices are high. Furthermore, it can be used for personalized treatment strategies in healthcare to find the best medication for an individual state of a patient. And in the energy sector, it can be used for dynamic load balancing. For example, to learn how to charge an electric vehicle whenever renewable energy sources are available. So let's talk about the fourth core type of machine learning approaches, which is self-supervised learning. It uses raw, unlabeled data to create pseudo-labels, allowing models to learn meaningful patterns without relying on external supervision. It's actually pretty similar to supervised learning, with the only difference being that the labels are derived from the data and not annotated by humans. And it is used actually for training large language models. So we have raw text, for example, from internet websites or books. And now the labels are derived from the data itself. So for example, if we have the sentence, "the sun is shining," we get rid of the last word and use this as an input for a supervised learning task. And we know the desired output label is shining. Now the machine learning model tries to map this input to that output. Or for example, the sentence, "apples are fruits." So we get rid of the first word and use this as an input for a supervised learning task. And this is actually used in chatbots. So if you ask, "what is the sun doing?" it knows the sun is shining. Or name a fruit, it knows apples are fruits. So let me mention here that chatbots also use additionally reinforcement learning. Now this is the end of my video about the core approaches in machine learning as far as I see it. Obviously, there's a lot of research going on in this field, so stay hungry for knowledge, my friends.